friends, welcome to CEC lectures. Myself Dr. Preeti Thagwani. I am from Department of Computer Science, Arbat College, University of Delhi. So presently we are learning about database management systems in our series Database DBMS, and in our previous lecture we have started with the topic of query languages, and we have also covered one procedural query language which was relational algebra. So our today's agenda is about the SQL, or we are going to introduce SQL, and then we will be taking after the overview of SQL, which is a structured query language, we will be taking some basic query structures, some how to define the tables or relations, some data definitions about it, some additional operation and some set operations. So in this flow we will be taking our today's lecture. So when we talk formally about this structured query language, so earlier if you can see this was actually a project at IBM St. Joe's Research Laboratory, and it was known as IBM SQL language, which was developed as part of System R project at IBM Research Laboratory at St. Joe's. Then later on it was renamed as, from SQL it was renamed as SQL, which is a structured query language. If we look into the versions, what all versions were there. So there are there can be NC versions of SQL, there can be ISO standard SQLs. So it started from the first version, which was SQL 86, then came SQL 89, then further there was a version of 92, then SQL 1999 and SQL 2003. So in these in this flow, in these versions, the SQL is actually developing, we can say. Then if we talk about what actually it is and what all are parts of SQL. So as the name indicates, a structured query language, it is a query language, and what is actually a query language, that we have covered in our previous lecture. But just to recap, that the query language here is what you can say is something or a technique which is there in order to extract the information from the database. Now query languages are not only limited to extracting the information, but apart from that many other we can say tasks can be achieved with the help of these kinds of structure, particularly SQL if we talk about. So all these task achievements are actually counted as parts of SQL. So what are the parts of SQL, that we will see. So first part comes as data definition language, which is DDL. Then next comes as data manipulation language, which is DML. Then there is a part about integrity constraints or maintenance of integrity constraints. Then we have some specific view definition commands into our SQL. Then we have facilities or techniques for controlling the transactions, and we also have embedded SQL and dynamic SQL are also part of our SQL entire technique. And apart from that we have authorization facility also. So we will be covering all these parts of SQL one by one. So the first part which comes as, it is DDL, which is data definition language. So the data definition language is that part of SQL which provides commands for defining the schemas, the structures of the databases, for deleting the relations, for deletion of the tables, and modifying the relation schema. So if we want to create it, if we want to delete it, or if we want to modify any table, or if we want to modify any relation schema, the commands which we will be using, those commands are actually falling under data definition language, which is DDL. The next part comes is DML, data manipulation language. So the term here is manipulation. That means it provides the ability to query the information from the database, and also we can say to modify the database or modify the data inside the database. We are not able to modify the database or modify the table using DML, because that part falls into data definition language. That whole, if relational schema or if table has to be modified, the structure of the table has to be modified, then that comes under data definition language. But if we talk about modification of data, that is modification of tuples, we can say, or the data inside that, or we can say deletion of tuple or insertion of tuple, or even kind of querying the information from the database. All these queries or all these commands basically comes under the umbrella of data manipulation language. So, data manipulation language, which is SQL DML, that provides the ability to query the information from the database, and not only the querying the information, but inserting the tuple, deleting the tuples, and modifying the tuples too. Then going forward, the next part is about maintenance of integrity, and we have also seen what actually integrity constraints are. So, here the SQL data definition language includes the commands for specifying integrity constraints that are stored in the database, that the data stored in the database must satisfy, and any violation about the integrity constraints is actually not allowed. So, maintenance of integrity constraints, or the commands which are there for maintenance of integrity constraints, also comes under the SQL DDL, we can say. Then apart from this, definition of views, different users or different roles can have different views. So, the SQL DDL also includes the commands for defining views. Then comes transaction control. So, SQL also includes the commands for specifying the beginning and ending of the transaction, and all these parts we will be seeing more detail along with the examples and queries commands we will be seeing in a short while. Apart from that, we have embedded SQL and dynamic SQL also, that define these how SQL statements can be embedded within a general purpose programming language. If we are talking about the embedded SQL, any general purpose programming language such as C, C++ and Java can use can embed these SQL statements. So, that technique comes under embedded SQL. And apart from embedded SQL, one more technicality is there, which is about the authorization. This comes under the DDL thing. So, the SQL DDL includes the commands for specifying access right to relations and views. That means which role can access which particular relation and in which mode. Is it only view mode, or is it it is just is it view, read or write mode, and so on and so forth. So, all these things comes under authorization commands, and these authorization commands are actually part of SQL DDL. So, all these are your authorization, your embedded SQL, view definition, transaction control, integrity constraints maintenance, data definition language DDL and DML. All these are known as parts of SQL. So, let us begin with data definition language, which is DDL. So, SQL DDL allows the specification of information about the relations, about the tables. Now, what information can be specified using DDL? So, one is the schema of the relation, which is the overall structure. Then we have domain of the values associated with each attribute, that which particular attribute is coming from or what will be the domain of which attribute. So, for example, we can say we have roll number. So, roll number is actually essentially it should be of from domain integer. So, that can be defined so, or apart from that also the integrity constraint. So, how this schema has to be defined, how the domain value is associated with, or what kind of domain values are associated with each attribute, what all will be the integrity constraints in order to maintain the integrity of the data. Also some other information, for example, the set of indices to be maintained, security and authorization information for each table, for each relation, and the physical storage structure of each relation on the disk. All these we can say things can be maintained using your SQL DDL. So, when we talk about the schema for each relation, that means we need to define the name of the relation, we need to define the number of attributes or we can say number of fields. Then apart from name of the field, one must specify that what is the domain of the that particular domain of the data from which data for that particular field is going to be derived. So, these are basically known as domain types in SQL. So, what all domain types are available in SQL? Let us have a look at that. In some literatures you can also say these are the data types of the data which is going to be stored inside the relation or inside the table, but the more appropriate term is about these things is domain types. So, first domain type here is char n, where n is actually the length, char as in character. So, basically if we are going to define a particular attribute as of the domain char n, that means that particular attribute will have character data, will have fixed length character string along with the user with the user specified length as n. So, for example, if I am going to say char 10, so that means that particular field will contain the fixed length character string and that fixed length is 10. Now, why I am saying fixed length, that that concept will be clear then when I am talking about varchar. Varchar is variable length character string with user specified maximum length n. Now, what is the difference between char and varchar? So, when we talk about, let us say, char n, so here for example, in this field I am going to write the term, let us say, welcome. So, welcome is going to take 7 spaces, or we can say the length of the string welcome is 7, but it is going to take a space of, we can say 10, because the the length of the character string is fixed here and that is 10. Whatever you are going to give here will whatever data you are going to include here will take the length fixed as 10. In varchar it does not happen. These are variable length character string and n here is the maximum specified length. So, when we talk about varchar, that means, so for example, in varchar 10, if I am going to write welcome, or if I am going to insert welcome, then it is going to take a space, or it is going to take a length of 7 characters, while 3 characters will not be we can say used because it is not required. Now, here variable length character strings can be stored. In character end, the character strings which can be stored will be of fixed length, which is equals to n. Here n in case of varchar is just the maximum length. That means any character string which is having the length more than 10 will not be stored inside this varchar n. Then comes integer, int, as in integer we all understand, which is a finite subset of integers, that is machine dependent. It could be 2 byte, or generally it is we can say it is of 4 bytes. Then it is having a small int, which is a small integer, again a machine dependent subset of integer domain type. So, integer is actually, we can say, is the superset, and a small int is for the it is actually a subset. Then we have apart from integer, if we want to, let us say, store salary or any percentage, so that can have a floating point value, or that can have a value after the, we can say, after the decimal point. So, all these values will be stored under domain numeric, in which 2 particular values will be specified, which are more commonly known as p and d. So, we call it as numeric p comma d. So, basically this is a fixed point number with user specified precision of p digits, with d digits to be the right of the decimal point. So, the total precision is going to be p digit for that particular number, and that is a fixed point number, and d digits will be on the right of the decimal point. So, for example, if we are writing numeric 3 comma 1, so numeric 3 comma 1 allows 44.5 to be stored. That is fine, because the total is 3 and after decimal it is only 1, but it will not allow anything like 444.5, because it is exceeding that particular value of p, which is 3. or even it is not, we can say allowed to store 0.32, because we have specified D, which is the digits to the right of the decimal point, as only 1. So we will not be able to store 0.32. So those constraints you need to be careful with. Then there comes real double precision, which is about the floating point and double precision floating point numbers, and these precisions are actually machine dependent. Then we have the float n, which is floating point and with user specified precision of at least n digits, and there are many more. So in this domain types in SQL, we have seen fixed length character string, which is character, then variable length character string, which is varchar, then they have int, then they have small int, apart from that they have numeric, and then real double precisions or float and there are many others which we will be which we will be learning as and when it comes in the context. Now with this, let us start with our first construct, or we can say let us start with our first command in the category of DDL, which is about the creation of a relation, or which is about the creation of the table. Now when we talk about a table, it must have one name which is unique, then it must have how many fields we can have, what will be the data type or what will be the domain type of that particular field, and if there are any integrity constraints. So the syntax, the proper syntax of the SQL create table command goes like this, that is create table R. R is the name of the relation, and within the bracket we will be writing the attribute names and the data type of the values in the domain of the attribute. So for example, if we are going to write create table R A1 D1 comma A2 D2 comma A3 D3. So A1 D1 as in A is the name of the attribute, D is the domain of that attribute, A2 is the name of second attribute, D2 is the name of second attribute, and so on and so forth. Here we can also, before closing the bracket, we can also specify some integrity constraints, which can be many, integrity constraint 1, integrity constraint 2, and so on and so forth. So basically in its kind of very bare format, if we talk about, we need to have one name of the relation, then the name of the attributes and the domain type of the attributes. We can also skip the integrity constraints if they are not required or if they are not appropriate. So this was the basic structure. Let us take it with an example. So here we have create table instructor. The first attribute or the first field is ID, which is of character 5, which is of the type character 5, or specifically we can say that the ID is of type character 5. Then there is name, which is obviously intuitively we can say it is the name of the instructor, and varchar 20 has been assigned as the domain. Then it is having department name, again varchar 20, and then salary, which is a numeric figure. Total value of P here is 8 with 2 digits allowed after decimal point, and then there is the closing parenthesis. So here we can say create table instructor open parenthesis, the first pair, which is ID char 5, name and the domain, comma, then name varchar 20, the second pair, comma, department name varchar 30, then we have comma, salary numeric 8 comma 2, and then a closing bracket. So after execution of this particular command, a table instructor will be created inside the database, and that table instructor will be having 4 fields. One is ID, another one is the name, department name, and salary, where ID, name and department name are character and varchar respectively, and your salary is a numeric value, or salary, the domain of the salary attribute is numeric. Then what all could be integrity constraints? So, when I was telling the syntax of this create table, so I told you create table R, which is the name of the relation, and here we have seen it as instructor. So, create table R, within the bracket you will specify the names of the attributes and the domains of the attributes. But apart from that, what third thing we can specify within this create table is about the integrity constraints. Now, what all integrity constraints could be there? One integrity constraint first is not null. Then we have the integrity constraints primary key. What primary key you need to make? There can be multiple. There is a there can be more than one primary key is taken as composite. So, A1, A2, A3 till AN, and there will be foreign keys starting from AM to AN. It could be one or it could be more. References are. So, let us try to understand how these integrity constraints are working within the create table command. So, here with the similar command in of the previous example, I have in which I have taken create table instructor. Now, after this name varchar 20, I have specified before the comma, I have specified not null. After department name there is nothing, then they have salary, and before we can say closing the bracket of the command, or before terminating the command, we will say primary key within the bracket ID, that instructs the machine or that instruct the system to make ID as the primary key, and foreign key is the department name which is being referenced from the table or the relation department. That is basically department name which is being included here is actually the primary key of the relation department, and here it is going to be used as the foreign key. So, we will be writing foreign key within the bracket name of the attribute, which is department name here, references, and then name of the relation, and after this we can close our bracket, and we can say the command is complete. I will repeat the command, that is create table instructor, ID care 5, name varchar 30 not null, department name varchar 20, salary numeric 8,2, primary key is ID, and foreign key is your department name which is coming from the relation department. Now, one thing which is we need to be clear about, that if we are going to define any key as primary key, that means that that primary key declaration on an attribute automatically ensures not null. So, along with the primary key we need not to define not null. So, primary key is having qualities of being not null as well as of being unique. So, here we have taken ID as the primary key, that means ID will be null value or nothing in a way. Null value cannot be inserted inside the ID. Also, the ID will be unique because it is being taken as the primary key. Then name, here we have already specified that there should be not null. Department name is the foreign key which is coming from the relation department, and then there is salary presently which is without, we can say without any integrity constraint. So, here is the total structure of the command which is create table along with the integrity constraints. Now, let us see some more examples of this. So, for example, we have we need to create a table student in which there are ID, name, department name, total credits, and then we need to define the ID, student ID as the primary key, and then we have department name as the foreign key. So, here we can write create table student ID varchar 5 of 5 length, then we have 5 length as maximum, then we have name varchar 20 if we want to specify a not null characteristics apart with this. So, we will be writing not null. Then the third one is department varchar 20, Then we have total credit numeric 3,0. That means it is not going to take any we can say digit after the decimal place, in which the ID will be the primary key and the department name which is being taken here is taken has been taken as the reference from the department as a foreign key. So, here we have seen two basically examples of your create table thing, and before that create table we have also seen domain types in SQL, and we have seen what actually SQL is and what are the parts of SQL. We will be covering more SQL commands in our upcoming lectures. Till this, hope you have enjoyed and had a fruitful please have fruitful learning. Here is the list of references which is being used for the preparation of the lecture. I will see you in the next one. Till then, take care. Goodbye.